Hello friends, welcome to the Engineering Projects YouTube channel. I am Mariam. We have started the series of electronic devices and circuit theory by Robert L. Ballisted. We are at chapter number 2 and its name is Semiconductor Diode Applications. In our previous lectures, we have discussed about the clippers, clampers, rectifiers, and in our today lecture, we will discuss about the voltage multiplier. In this lecture, we will discuss about the voltage multiplier definition, its types, and it has 3 types. And number 1 is voltage doubler. It may be of half wave and full wave, and voltage tripler and voltage quadruple. In this lecture, we will discuss about the half wave voltage doubler and the full wave voltage doubler. Voltage tripler and the voltage quadruple will be discussed in the next lecture. So what is voltage multiplier? It is an electrical circuit that converts the AC electrical power from a lower voltage to a higher DC voltage, typically using a network of capacitors and diodes. So it will convert the AC electrical power. This is the AC electrical power. From a lower voltage, it's the lower voltage, this is Vi and its maximum level is Vm, to a higher DC voltage, its maximum level is 2 Vm. So, to a higher, this is DC voltage, this red line shows the DC voltage, typically using a network of capacitors and diode. It will use the network having the capacitors and diodes. Its second definition is a voltage multiplier is a specialized rectifier circuit producing an output which is theoretically an integer times the AC peak input, which is the integers times the AC peak input. It is the 2 times the AC peak input. It will be the 3 times of AC peak input. It will be the 4 times of AC peak input. It has types. When output voltage will be equal to 2 times of AC peak input voltage, then we will call it as the voltage doubler. It has 2 types. It has half wave voltage doubler type and the full wave voltage doubler type. We have discussed that a voltage multiplier is a specialized rectifier circuit. What is the difference between the rectifier and the multiplier? We have discussed that in our rectifier lecture. Rectifier basically convert the AC into DC, AC input signal into the DC input signal. When we have AC signal like this, then our rectifier circuit will provide us the DC like this, like this. So this blue line will show the rectifier output, but this red line shows the multiplier output. The multiplier basically multiplied the peak inverse voltage, peak voltage to the multiplier circuit basically is the integer times the AC peak input, integers times the AC peak input. So example, if peak AC input is Vm, the DC output voltage can be 2 Vm, 3 Vm, 4 Vm. Vm shows the maximum voltage, etc. Its types are V0. These are its 3 types: voltage doubler, voltage tripler, voltage quadruple, and it has more types. It may have 5 Vm, 6 Vm. It depends upon your demand. So now, half wave voltage doubler. Our book contains the topic only voltage doubler, tripler and quadruple. So we will discuss about only voltage doubler, tripler and quadruple. We will not discuss about the next voltage multiplier types. Half wave voltage doubler. This is the circuit diagram of half wave voltage doubler, and this is our transformer. This is our capacitor, this is diode D1, diode D2, and this is our capacitor number 2. This is capacitor C1. This is capacitor C2. Now we want to charge this capacitor. To charge this capacitor, our diode should be forward biased. When our diode is reverse biased, our capacitor will not charge. So this is P type of our diode and this is N type of our diode. To make our diode forward biased, there should be a positive and there should be negative. So we first have to take positive half cycle. When there is negative half cycle, our capacitor will not charge because our circuit will be open here. So for positive half cycle, our diode will be forward biased and it will act as the closed circuit here. It will act as short circuit. Now current will flow in this direction and our capacitor will be charged. When our capacitor is charged, it will charge to the maximum voltage Vm. This is our input voltage Vi and its maximum level is Vm. So our capacitor will charge till the maximum voltage level, which will be Vm. When negative half cycle came, there will be negative and there will be positive. For positive half cycle, our capacitor have the for positive half cycle, our capacitor has the polarity plus and minus, plus connected with plus. For negative half cycle, the polarity at the capacitor will remain same. The polarity at capacitor will not change because it is in the charge state. For negative half cycle, there is negative. Our diode D1, which is in this shape, our diode D1 will be reverse biased and our diode D2 will be forward biased. So D1 will act as open circuit like this and D2 will act as short circuit. Now our input voltage have the maximum value Vm. Our capacitor is charged at the maximum value Vm. So at this point we will have 2 Vm. Vm plus Vm will be equal to 2 Vm. Now our current will pass positive to negative in this direction. Current will pass in this direction. Applying the Kvl equation. Now apply the Kvl equation. So I am starting from this negative point. We have to write the polarity for this capacitor. This plate will be positive and this plate will be negative. Now write the Kvl equation. Here is negative minus Vm, which is the input voltage, plus C2 minus Vm is equal to 0. So C2 polarity will be equal to 2 Vm. So our C2 capacitor will be charged at the till 2 Vm level. We want to take our output across this capacitor. We want to take our output at this terminal. So at this terminal we will have the output value which will be equal to 2 Vm. Our output will be equal to, we want to take output V0 at this point and V0 will be equal to 2 Vm. So our rectified our multiplied output will be shown as, this is our output, this is our input and this is our output. Input, this is the peak input value and this is the peak output value. So our peak input value is Vm and our peak output value is 2 Vm. So it is the integer multiplier. It is the integer times the AC peak input. So this is our circuit. Now we will discuss about the full wave voltage doubler.